Today I'm going to talk about LeetCode question number 226, invert a binary tree. Given the root of a binary tree, invert the tree and return its root. So for example here, we have the root up here, and then its children are inverted, and then their children are inverted. So then 7 becomes, instead of on the right, it becomes on the left. And then we have 6 and 9 down here. 9 becomes on the left, and 6 becomes on the right. Okay, similarly for 2. Okay, so basically with this problem, all we really have to do is traverse the tree and invert the children every time. Okay, for example, we have 4, 2, 7, and then they have their own children, but I'll focus on these for now. So first iteration, so 4 is 4. Okay, the root is always going to stay the same. There's nothing for it to be inverted against. Okay, and we invert these two. Okay, and then they have their own children actually. So I guess I'll just draw it here. That's 6, that's 9, that's 1, that's 3. Okay, and then here, once we invert these children, this becomes 6, 9, and 1 and 3. Okay, and then you have to go here and here and invert those. 4, 7, 2, 9, 6, 3, 1. Okay, and then since these guys don't have any children, we're pretty much done. Okay, so that's how we go. We go for each child by child. We're going to do this recursively because that's just the easiest way. And then, so we're going to traverse down the child, reverse its children, and then go explore that child and reverse its children, and etc. Okay, and for this will take n time because we're pretty much visiting every node in the tree once, and it's the number of nodes in the tree. And yeah, that's pretty much it. So now to code this up, what I'm going to do first is to take care of an edge case. So if root is none, return none. Okay. Else, what I'm going to do is define my helper function. This is going to be recursive. So my base case will be if root is none. So if we have like a none root, if we have like a none here, obviously it doesn't have any left or right children. We have to stop the execution there. So return this return. Or else, what I'm going to do is just define my left child is equal to root dot left, right child equal to root dot right. So in these variables, if I'm here at root, I'm define the left child as this whole subtree here starting from 2, and the right child as this whole subtree here starting from 7. And then basically I'm going to swap them. So root dot right equals left child, and root dot left is going to equal to right child. Yeah, so I basically swapped them. So now there's 7 subtrees here and there's 2 subtrees here. Now we have to visit their children and swap their. Now we have to visit these nodes and swap their children. Okay, so I'm going to recursively call helper on root dot left and helper root dot right. Okay, and yeah, that's pretty much it. So in my outside of my code, I'm going to call helper on root, then return root. So I'm going to run it. Okay, looks good. Now I'll submit. Okay, great. Thanks for watching.